Say, meron tayong ganitong function. Then we consider this region, tapos bubuo tayo ng solid of revolution by revolving this region about the y-axis. Maybe we can visualize yung result ourselves, no? And it makes sense naman na ganito yung magiging result niya. So let's go back to the Cartesian plane na starting point natin. If we are to use yung previous method natin of disks or washers, ang approximating area natin would have dy as its thickness. That is to say, perpendicular siya sa y-axis. Pero pag naglagay tayo ng approximating rectangle na perpendicular sa y-axis, for this particular case, magkakaproblema tayo kasi may region na mapuputol si approximating rectangle. The function also fails the horizontal line test. So if we attempt to do the integration along y, hindi magiging function yung ating integrand. We are forced to consider using an approximating rectangle na perpendicular sa x-axis. Now let's try rotating this region about the y-axis. We can see that it will trace out a thin hollow cylinder or a cylindrical shell. So instead of working with the disk or a washer for our differential volume, let us consider this cylindrical shell as our differential volume. Zoom in tayo para ma-visualize natin yung thickness ng shell. At gamitin natin yung formula ng volume ng hollow cylinder na pi times the quantity of the square of the outer radius minus the square of the inner radius times the height. In the figure, we've also marked the midpoint of R sub capital O and R sub capital I. Siya yung may label na M for midpoint. Pero itong cylinder ay yung differential volume nung buong solid of revolution. Kaya label natin siya ngayon na delta V. Equal pa din naman siya dun sa formula sa taas. Notice na difference of two squares yung expression ng mga radius or radii. We can factor it out kasi difference of two squares nga siya. Yung expression na R sub capital O minus R sub capital I, that will give us the thickness of the shell. Ngayon, i-compare natin dito yung ith approximating area that will generate this ith cylindrical shell. We can correspond the height of the shell with the value of the function sa midpoint, R sub capital O with yung x sub I minus 1, R sub capital I with x sub I, at yung thickness given by R sub capital O minus R sub capital I with delta x. Pero si midpoint M sub I, hindi ba siya mismo yung average nung x values nung endpoints nung interval? So, equal siya sa 1/2 times the quantity x sub I minus 1 plus x sub I. So, yung sum nung interval endpoints x sub I plus x sub I minus 1 equal siya sa 2 times m sub I. Let's rewrite our delta V now as follows. Pi times f of m sub I, which is yung height, times 2m sub I, which is yung outer radius plus inner radius, times delta x. Rearranging the factors, we have 2 pi m sub I times f of m sub I times delta x. So ito ngayon yung volume ng isang approximating volume na cylindrical shell. We now approximate the volume of the entire solid of revolution using multiple cylindrical shells. Then to get the exact volume, we let the number of shells approach infinity, which is the same as saying that we are letting the thickness of the shells approach 0. If the thickness of a shell approaches 0, yung volume din niya approaches 0, so differential volume na lang siya. In which case, delta V becomes dV. Si m sub I may ipit between the endpoints of the interval, kaya siya magiging x na lang. Si delta x magiging dx, and we'll have this expression for dV. Then the total volume is the sum of all the differential volumes, which we'll write as the integral of dV. Again, integral of dV, ito yung a-add natin lahat ng individual dVs, which is equal to 2 times pi times the integral of x times f of x evaluated from a to b, bringing us to our desired result of an integral that will give us the volume of a solid of revolution using cylindrical shells. As with our discussion sa method of disks and washers, the critical part here is understanding how to set up the correct integral. More often than not, the computation of the definite integral is the easier part. So on our next video, we'll look at some examples to practice this method. So stay safe at salamat sa pakikinig.